Hey guys, so today's lesson is on graphing quadratics. We're kind of taking everything that we've done already and just putting it all on a graph. In order to complete this lesson, you need to be familiar with standard form and vertex form, which should be no problem. We've covered this in previous lessons and we've also covered it in class. Bear with me, I'm doing a voiceover. I recorded this before, but my mic wasn't on, so here we are. Okay, so the only new formula is an axis of symmetry formula. I wrote it down for you. It's x equals negative b over 2a. It's a formula you can use on any equation in standard form to find your axis of symmetry, which can obviously help you find your vertex. So on this worksheet, which is your homework, I'm doing number 1 and 2 with you. First thing I'm doing is helping you find the axis of symmetry. So first step is to identify your A and your B. Our B value is -8. Remember, your A and your B values do not include your variable. It's just the coefficient. Your A value is 2. It's the leading coefficient. As soon as you have that, you can substitute into your axis of symmetry formula, which I like to call AOS. So the axis of symmetry formula is x equals, because your axis of symmetry is an equation, and then I substituted -8 over 2 times 2. The two negatives make a positive in the numerator. Your denominator is 4. 8 divided by 4 is 2. So your axis of symmetry is at x equals 2. But in our little chart, they don't ask us for an axis of symmetry. They ask us for a vertex. So if I know the axis of symmetry is 2, I know the vertex starts with a 2 because it lies on the axis of symmetry. So we can use the axis of symmetry and substitute to find our vertex coordinate. So I want to find my y coordinate. So I'm going to plug in or substitute x equals 2 into my equation that I had. So this is my original equation that they gave me. Replace every x with 2 and then simplify. Follow your order of operations. I kind of did this all in one step. 2 squared is 4, and then the 4 times 2 is 8. Bring everything else down. 8 times 2 is 16. Bring down your plus 6. Go from left to right. 8 minus 16 is -8. Bring down your plus 6, and then y is equal to -2. So now that we have our x coordinate and we have our y coordinate, we can finally write our vertex. So your vertex is going to be 2 comma -2. So it's your axis of symmetry comma your y coordinate that you found once you substituted. It took me a while to write that down, but here I am writing it down. Perfect. After that, we're finding our x-intercept. Now, for your x-intercept, you need to find that by solving for x. Now, we found that there's a lot of ways to do that. You could solve by factoring. You could solve by completing the square. You can solve by using the quadratic formula. This one works out nicely where I can solve by factoring. So for the x-intercept, again, you're solving for x. And x-intercepts happen when y is equal to 0. So whenever you're solving for an x-intercept, make sure you replace your y with 0. I made a note of that on here. But I'm just rewriting my equation, but instead of y, I'm writing a 0. And then I'm trying to figure out how to factor this. Now, when I looked at this, I noticed that all of my terms are divisible by 2. So I'm factoring that out. I'm actually dividing it out. Since I'm solving, you're able to divide it out. And I'm left with 0 is equal to x squared minus 4x plus 3. After that, I have a trinomial that can be easily factored. I use the x method. So two numbers that multiply to 3 add to -4. -3, -1 works. So I have 0 is equal to x minus 3, x minus 1. And then I solved by setting each factor equal to 0. I have x minus 3 equals 0, x minus 1 equals 0, and then solving for each. So on the left-hand side, I'm adding 3 to both sides, and I'm left with, I'm sorry, I'm tired of talking. I have x equals 3, and then on the right-hand side, we have x equals 1. So those are your two zeros. So just write those in the box. The last step or not the last step, the second to last step, is to solve for your y-intercept. So for your y-intercept, you're going to have to replace x with 0. But it looks like I started plotting. Okay, so let me talk about why I'm plotting. So I'm plotting my x-intercepts and my vertex. This is just to give me an idea of what my graph is going to look like. So the x-intercepts just go on your x-axis. The vertex, it's just a point. Go to the right 2, down 2, because that's what my vertex is. I don't know what I'm going to do next. Oh, I'm talking about concavity. So my graph is going to be concave up. I know that because my leading coefficient, my A term, is positive. Okay, this is something we talked about back when we were in class. So last step is to find our y-intercept. Y-intercepts happen when x is equal to 0. So you're just going to take your function, rewrite it, and then substitute 0 in for x. So I'm rewriting it, and then I'm replacing x with 0 in the following step. So I have y equals 2 times 0 squared minus 8 times 0 plus 6. Anything multiplied by 0 is going to be 0, so you can cross that out. I have y is equal to 6. That's your y-intercept. So I went ahead, filled that in my box, and then also plotted it on my y-axis. Just go up 6 units. Couple more things that I did. Next, I also graphed my axis of symmetry. My axis of symmetry, which I found, that was the first thing I did, is at x equals 2. Remember, it's an equation. It needs to be x equals, it's not just 2. And I noticed that, since I'm going to be graphing this, I noticed that my y-intercept is 2 units away from my axis of symmetry. So I know that there's another point on the right-hand side that's also 2 units away. So you don't need to draw the extra point, but I'm drawing it to help me get a better picture of what my graph is going to look like, so I can connect and have a smoother curve. So that's what I'm doing now. When you connect, make sure you don't have any sharp corners. It should be a smooth curve. Make sure you're going through your vertex and you're following all the information that you found on your left-hand side, and that you have arrows at the end of your parabola. Okay, halfway done. Number 2. For number 2, your equation is in vertex form. So that one's a little different. You're not using your new formula, your x equals negative b over 2a. There's an easier way to find your axis of symmetry. It's actually already written in your formula. We talked about this in class before, but I will talk about it again to refresh your memory. So your axis of symmetry is your h value. So remember, it's y equals a times x minus h squared plus k. That's your equation of a parabola that's in vertex form. So again, your h is inside. And if you want, you could take the inside and solve for x, but you don't need to. It's positive 3 on the inside. That means it's going to be negative 3 on the outside. Your k coordinate stays the same. That's outside of parentheses. So the plus 4, that's going to stay as positive 4. So there's your vertex. Next up is your y-intercept. Remember, your y-intercept happens when x is equal to 0. So I'm just rewriting my equation for my quadratic, and then I'm going to substitute x equals 0 whenever I see a 0. So that's what I'm doing now. Remember that you're following your order of operations when you're solving for y. So take care of the inside of parentheses first. So we have y is equal to negative 1/2 times 3 squared plus 4. Next thing is the exponent. So negative 1/2 times 9 plus 4. Negative 1/2 times 9 is going to give you a fraction. Just multiply your numerator and denominator across. You're going to have negative 9/2 plus 4. And then you need to find a least common denominator so you can actually add your fraction. So your 4 is not written as a fraction, so just throw it over 1, and then multiply your numerator denominator by 2 to get an LCD. As a result, you will have y equals negative 9 over 2 plus 8 over 2. And then now that you can add those, you get negative 1/2. So all that work to find your y-intercept, which is negative 1/2. All right, last step is to determine your concavity. Our parabola is concave down because my leading coefficient, my a value, is negative. Okay, so this gives me a good idea of what my graph looks like. From here, I can go ahead and start plotting to give me an idea. So the first thing I did was I plotted my vertex. It's at negative 3 up 4. I plotted my y-intercept. It's at y equals negative 1/2. I know that I have an axis of symmetry going through negative 3. It always goes through your vertex. And then it's always your x-coordinate of your vertex. And then I know my parabola is going to be concave down, but I only have 2 points and I want an extra point. So I'm kind of mirroring the y-intercept over on the left-hand side to give me a better idea of what my parabola is going to look like. So I just mirrored that over, and then I'm trying my best to connect this into a smooth parabola with no sharp corners, with arrows on the ends. It takes me a couple tries, but I got it done. So when you submit your homework, I expect to see all of your work shown. There's a lot of work that goes into these problems. That's why I'm only leaving you 2 problems for homework, number 3 and number 4. One's in vertex form, one's in standard form. You could follow my examples. I also attached an extra video that you can look at if you have any questions. Just let me know. All right, bye guys.